Okay, so last day we started our first lesson of the new unit. It's called rationals, which sort of means fractions. More direct or more literal translation is any number that can be turned into a fraction. So whole numbers and decimals do count as long as they can be converted into a fraction. Right? The word simplify can be interchanged with the word reduced, lowest. Right? It means make the fraction smaller. We make the fraction smaller by dividing the top and the bottom by the same number that can fit into both things. And when you get this new fraction out, that new fraction is a smaller version of the original fraction, but it has the same value. You didn't change the value, just how it looked. All right? So we talked about these, and when you don't change the value, just change how it looks, they're called equivalent fractions. Equivalent, the word equal was inside of there, right? Right? And so, how do you find equivalent fractions? By dividing the top and bottom by the same number, or going the other way. You can multiply the top and bottom by the same number, right? Not adding and subtracting, multiplying or dividing, right? So that gives you the same sets of numbers. Right? Quick recap on all this stuff. If we want to turn a fraction into a decimal, you take the top number and you divide it by the bottom number. Pretty straightforward, right? If you want to turn a decimal into a fraction, the top number is the number you see without the decimal, right? The bottom number is some sort of multiple of 10, 10, 100, 1,000. The amount of zeros you put on is how many numbers are past the decimal point. So this one had one number past the decimal point, so we had 1 0. Two numbers past the decimal point, 2 zeros. Three numbers past the decimal point, 3 zeros. Okay? Going over here. This is a mixed fraction. This is an improper fraction. Most of the stuff we're going to do this year is working with improper fractions. So you need to go from here to there. The denominator never changes. It stays the same. To get the numerator, you multiply the denominator with the whole number, then you add the top. Right? And the tricky situation was when you had a negative out front. If you had a negative out front, oops, that's not what I wanted it to do. Uh-oh, what are we doing? Computer. All right. There we go. So if you have a negative out front, we ignore the negative when we're doing that calculation. You go 7 times 3 is 21, and 21 plus 1 is 22. Right? And I'm hoping that one sort of makes sense, because positive and a negative number should be like the exact same value, right? So the positive version of this, 22 over 7, the negative version of it should be just on the opposite side of the number line, negative 22 over 7. Okay. Now, last little bit. Okay, occasionally you want to go the other way around. If I give you an improper fraction like this one, we want to make it a mixed fraction, right? The denominator doesn't change, but we need to figure out what is the whole number and what is the numerator. How do we do it? First step is to figure out what the whole number is. So if you have 13 over 5, what's that whole number? 2. 2. How did you get 2?
I see how many times the 5 would go into like 13.
Yeah. Whole number, how many times can the bottom number fully go into the top number? It can go in 2 times. 5 times 2 is 10, right? So that is here, we put the number 2, it goes in fully 2 times. And the top number, the numerator, is what is left over. Rob, what's that?
3.
3. So we have a remainder of 3. So we're trying to get to 13. All right, we have 5 times 2 is 10. And we're trying to get to 13, so we need another 3 more to go. 3. That's it. All right? Okay, so let's do some practice. I'll do one with you guys. Then I'll get you to do another one by yourself. Let's do this one as a class here. So denominator does not change. That stays the same. Whole number first. then the numerator next. So
5 fits into
12, how many times? Twice, thank you. So we put a big 2 left over, all right? Then we go, okay, we are trying to get to 12, right? We need another 2. 5 times 2 is 10. We need another 2 to get us up to 12. All right, I'll give you guys a couple of second head start. Do this one. Bottom number is 10. What's the numerator? What's the whole number? Figure those two things out. You can answer it in a second. And just give people a second to think and do it, right? How many times does 10 fit into the top number? What's left over? Right? Gabe, what is it? How many times does 10 fit into 32? 3 times. That gives us 30. What's left over? 2. So now technically, you could simplify that further. If it's 2 over 10, we simplify them. I'm not asking you to do that. All right?
Well, it does say in lowest terms.
Right? Oh, well, just not today.
Okay, just
Yeah.
like I'm understanding, you know.
Yeah,
the
it is
terms.
right. Yeah.
Okay, cool.
So now, the last one. How many times does 7 fit into 28? Cannon?
4.
4 times. So, how many are left over, Cannon?
0.
0. Be 7 times 4 is 28. And you have 0 over 7, and you don't need the 0 over 7, right?
Do we put a 1 instead of a 0? Or
No, because there's nothing left over. So we just change this to a 4, right? It fits in perfectly. There's nothing left over. You don't need the extra fractions. 0 parts of 7 are left over. So it fits in 4 perfectly, right? All right. Okay, next part over here. Common denominators come in handy in this year for 2 cases. When we want to compare fractions, what's bigger, what's smaller, you're going to be doing that next day in the day 2 lessons. Or if you want to add and subtract 2 numbers together. The other option is when we add or subtract, we need to have a common denominator, right? So, you're given 2 fractions. The word common denominators is you want to make the bottom numbers the same. That's what common means, right? Yes, Austin?
Can you zoom in on that? I can't really see.
Okay, I can zoom in, thank you. Right? Right? Change, so we need to change it, so the bottom numbers are the same, but we don't want to change the value. Right? You just want to change how it looks so we can compare them. We do that by multiplying the top and bottom by the same number. Same thing we did on the first page. Right? So we make it into the equivalent fraction, so it has the same value, right? And so you're looking for the same denominator, right? That's what common denominator means. So remember to multiply both the numerator and the denominator. That way you don't change the value. Okay. Now, a little bit of reality. You know, there's a reason why we do so many multiplication practices. Up to now, I think in grade 9 you'll be able to get away with it. If you're not strong with your multiplication table, or with multiplication, you can sort of get away with the calculator. That kind of phases away in grade 9 and grade 10. You sort of got to know what are the multiples, so you can, that just becomes a baby step and something bigger. If you can't tell where the numbers come from, math is going to get significantly harder. Just because you don't know what a number is made of. So we're going to do a lot of multiplication practice this year, and I'll help you out with giving you tips to get around with something we're doing, right? But if you're not strong with your multiplication, you may have to do extra practice beyond what we're doing in this class. Right? So here, I'm going to write these two numbers down. We're going to change them. Here's two fractions. The denominators are different. We want to make them the same. So we need to find a number that both 4 and 3 can fit into. Sammy? 12. And if you know your multiplications, these numbers just come up faster. If you don't know your multiplications, use your multiplication chart. Right? So if you don't see the answer 12 right away, on the very last page of this and the last page of your assignment, right, there is a gigantic multiplication chart. You're going to go here, right? You use that, you go, okay, one of my denominators is 4, the other one is 3, right? You're looking for what number can both of these fit into. So you look across both of these and you look for the same number. So for the people who don't see it, you go, oh, this has a 12, this has a 12, so my common denominator is 12. They can both fit into 12. So you can use it, so you just look across this, you go, oh, they fit into 12. That just happens to be the lowest one. They fit into other numbers as well, right? You have 24, you have 36, there's a whole bunch of them. We tried to pick the lowest one, right? It just makes the number smaller and easier to calculate and compare. It's not wrong if you don't see the smallest one and you end up going for a bigger one. That's nothing wrong with that. Just more calculations. Does that sort of make sense? So grab that table, look across. Here are my two denominators. Which ones are the same? Yes, William?
Can you just times them together like
So you can. So if you get completely stuck, and let's just do this one, and I'll touch back on that one, what you're talking about here. Okay, so here we go. I want to turn, oh, that's the mouse, 4 into 12. I have to times this number by 3, because 4 times 3 is 12. So I go times 3 here, and I go times 3 here. Top and bottom, because we're not changing the value, we're going to keep it equivalent. So this becomes 9 over 12. Now I do the same thing to the other side. I go, okay, I want to turn this 3 into a 12. So I have to go 3 times 4, right? 3 times 4, or 2 times 4. Whatever you do to the bottom, you do to the top, that becomes 8 over 12. So these two fractions are written with the common denominator. Okay. Now William says, hey, can't I just multiply by the opposite denominator? Yes, you can. That will get you a common denominator 100% of the time, but it may not be the lowest one. So if you're stuck, all right, you can always go, in this case it works out this way. Like in this one, you can always take the opposite denominator. Here's a 3. I'm going to multiply this one by 2. I'm going to multiply this one by 2, so I end up with 4 over 6. So you can always take the opposite one and multiply. So the opposite fraction is 2 here. So I'm going to multiply 2 on the top and bottom, and I can go 3 on the top and bottom on this one. And yes, we get fractions that have common denominators. Right? Now, that will always work. It may not just be the smallest fractions that you can create. In this case, they end up happening to be the smallest fractions you create. On the next one over, if we used the same technique, you go, oh, I can't figure out what the lowest denominator is. I can multiply the top and bottom by 12 here. I can do this by 8, so that means 12 times 8 is 96. That's the denominator you're going for. Right? There is a smaller one. Does anybody see the smaller one? Sammy? 24 works, right? If you don't see it, we go to our chart. You go to the last page. I gotta zoom this out. Come on. I should put this on a separate page. We have 8 here. We have 12 here. We look across. 24 and 24 work, right? But 8 times 12, if you did that one, that's 96. That also shows up, right? Not wrong, just not the smallest. So if you pick something that's bigger, it just means at the end, you're going to have to do more simplifying. So you have to do more work on the other end of it, right? So we're gonna go for 24 because it's the smaller one, right? So if I want to turn 8 into 24, what do I need to multiply the top and bottom by? Sorry? 3, thank you. 8 times 3, I go 24. So I got 24 and 15 on the top. Because 5 times 3 is 15.
And then
And if I want to turn the 12 into 24, what do I need to multiply that by? Thank you, 2.
and
So I'm,
14 over 24.
then we get 14 over 24. Okay? And that's it. So I'm going to give you out your assignment. I don't think we'll do the other set of notes. We'll see how it goes. So I'll give you out the assignment. And you can work on that. And I'll come around and help you as much as I can.